So learning target 29 is on factoring, which is a fancy word for dividing. But before we can divide or factor our standard form quadratic functions, I want to remind you how we got to the standard form from factored form. So we started by distributing both terms in the first set of parentheses to both terms in the second set. So I'm going to start by distributing my x to x, and that will give me x squared. X times 8 gives me positive 8x. Negative 3 times x gives me negative 3x. And negative 3 times positive 8 gives me negative 24. And then we would combine like terms. So we have y equals x squared. And the positive 8x minus 3x would give us a positive 5x minus 24. So what we're going to do now is talk about where these numbers in our final answer came from so we can see some patterns, and that will help us take an equation that looks like this and turn it back into one that looks like this. So let's start with probably the easier pattern to notice, and that is this negative 24. The negative 24 came directly from the negative 3 times the positive 8. The one that's a little bit harder to see is this positive 5. Well, it came from the 8x minus 3x. So when we look at our original binomials, it's getting a little messy here, I'm going to erase a little bit. When we look at our original binomials, we had 8 minus 3. So when we take a quadratic equation in standard form, we're going to be looking for two numbers that multiply to the constant and add to the coefficient of our x term. And because you can multiply in any order, if we had started with y equals x plus 8 times x minus 3, we would have gotten the exact same answer when we multiplied them together. All right, so I call this the T-chart method because what we do is we set up a T-chart. So we're looking for what multiplies to C, our constant. So we have to find two numbers that will multiply to 14, and those same two numbers have to add to B, our middle term, coefficient of our x. All right, well, when we're thinking about what multiplies to 14, the first two numbers that pop into my head are 2 and 7. 2 times 7 does equal 14, and 2 plus 7 does equal 9. Once we find the correct numbers, we just put them into our two binomials. So we have y equals x plus 2 times the quantity x plus 7. And what's nice about this, I should have put step 4, add step 4, check your work. Because you can always multiply those binomials and check to make sure that you actually got the correct numbers. So we're going to do that. X times x gives us the x squared. X times 7 gives us 7x. 2 times x gives us 2x. And 2 times 7 gives us 14. So when we simplify this, we get x squared plus 9x plus 14, which is what we started with, so we found the correct numbers. Same process, so we're going to start by setting up a T-chart. What multiplies to the constant 18 and adds to the middle term 19. First two numbers that pop into my head for 18 are 6 times 3. 6 times 3 equals 18, but 6 plus 3 does not work for 19. So I'm thinking 2 times 9. 2 times 9 is 18, but 2 plus 9 does not equal 19. What other numbers multiply to 18? Common number that's forgotten, or pair of numbers, is 1 times itself. 1 times 18 is 18, and 1 plus 18 does equal 19. So we got the correct numbers this time, so we're going to set up our two sets of parentheses. Sometimes I like to just throw my x's in there right away. And then we've got x plus 1, x plus 18. And we're going to check our work on this one. Y equals x times x is x squared. X times 18 is 18x. 1 times x is 1x. And 1 times 18 is 18. So when I combine my like terms, I get x squared plus 19x plus 18. So my answer checks. And let me clarify really quickly, because I was checking my work, that the answer to factoring is, this was our answer the first time, and this was our answer the second time. All the work we did after that was checking to make sure that our answer was correct.